We don't talk anymore.
Good day everyone, especially to Doc Fidelina Iliran. I'm Arlan J. D. Lucay-lucay, your reporter. In today's discussion, I will discuss the figure 8.2, the simple correlation line graph of perfect negative correlation of tests X and Y taken by 14 teacher education students. But I will not discuss the figure 8.2. Instead, I will present my own data based on the figure 8.2. And also, I will discuss the Pearson product moment correlation coefficient together with the formula. And lastly, I will discuss also the interpretation of correlation values. So let us discuss first the figure 8.2. But as I said earlier, I will present my own data based on the figure 8.2. This topic is connected to the report of Miss Estrella Aimee, which is she discussed the perfect negative correlation. So, before I will show to you my data, let us define first what is perfect negative correlation. Okay, so it is also a recap for you to be able to understand what is the report all about. A perfect negative correlation is represented by the value of negative 1.0, while 0 it indicates no correlation, and positive 1.0 it indicates a perfect positive correlation. A perfect negative correlation means the relationship that exists between the two variables is exactly opposite all of the time, which is if we create a line graph, the score of each student in test Y is an exact opposite in the test X, which means in the X is increases as Y is decreases. If a student get the high score in test X, she or he will get the low score in the test Y. It means to say that the one who get the highest score in test X, she or he will get the lowest score in the test Y. In the negative correlation, there is an inverse relationship between the two variables. So, when one variable is decreases, the other increases. The vice versa is a negative correlation too, which is if one variable is increases, the other variable is decreases. For example, if variables X and Y have a correlation coefficient of negative 0.1, they have a weak negative correlation. But if they have a correlation of negative 0.9, they would be regarded as having a strong negative correlation. Okay, so let us proceed to the data I will present to you. So this is the table. So in the table, it consists the number of 16 teacher education students, and also there is an X and Y, and after the X and Y, there are scores of 16 teacher education students. Okay, so another table. So in this table, it contains the cell A and B, which also called the cell X and Y. So in this table, it contains the number of 16 teachers education students, and also it contains the scores of 16 teacher education students. So in the cell A, it contains the scores of the 16 teacher education students, which is in the cell A, it starts with the lowest score, which is the 68, down to the highest score of 98. Then it is opposite with the cell B, because in the cell B it start with the highest score, which is the 98, down to the lowest score of 68. But you have to remember that it is not necessarily that you have to start with the highest or lowest score. For example, for my data 68, it is not necessarily that you have to start with 68, but it depends on the table of what is the score of what is the highest or lowest score in the table of the 16 teacher education students. Remember, it depends on the 16 teacher education students of what is their scores. Okay, since we are done presenting our table, Now let us create a line graph. Now this line graph, it is the simple correlation line graph of perfect negative correlation of tests X and Y taken by 16 teacher education students. So let us define first what is line graph. So when we say line graph is also known as a line plot or line chart. Is a graph that uses lines to connect individual data points displaying the quantitative values over a specified time interval.
And to create a line graph, you have to draw a horizontal and vertical lines.
So first we have to create a horizontal lines. And also we have to create a vertical line. In this side, it is represented as a y-axis, and this side is represented as a x-axis. So in this side, you have to put the test y. Test y. So in this side, you have to put the test x. Test. So during my last discussion, as you can see, this point here is also called a vertex. Now we need to put a 0 here. So remember, this is a vertex which is the starting point of the number. Now, since in our table, there is a test x, cell x and y. So in the score of 16 teacher education student, the lowest score is 68 and the highest score is 98. So let us start count with 68 up to 98. And this side in the test x, let us also count 68 to 98. Okay, we are down. We are done. So as you can see in the table that in the cell A, it increases while the cell B is decreases. Now since it is opposite, now let's start with the cell A. Since the cell A is increases, so let's start with the 98, and the opposite of 98 is 68. Now let us put here a dot here with the point of 68 here. Next is the 96 and 70. The opposite of 96 is 70. So let's put here a dot. Now, third one is the 94 and the opposite of 94 is 72. As I said earlier that if a student get the highest score in the test X, in the test Y, the student will get the lowest score. Now, if the student get the highest score here in the test X, which is the 92, now in the test Y, she or he will get the lowest score in the test Y. Here in the 74. So another, if the student get a highest score of 86 in the test X, the student will get a lowest score in the test Y, which is the 78. Now let's put a dot here, connect with the 78 and 86. Now another, if the student get a highest score in the test X of 84, now the student will get a lowest score of 80 in the test Y. Now, there is an inverse relationship between the test X and test Y. Now, in the test X, if the student get the lowest score of 78, the student in the test Y will get the highest score, 84. Now, let's put here a dot. You have to remember that you have to align the dot in the 78 and the 84. Now, another. In the test X, if the student get the lowest score, the opposite of 76 is get the highest score in the test Y. Okay, another, if in the test X, if the student get the lowest score of 72, she or he will get the test in the test Y of highest score, which is the 94. So let's put a dot here, and you have to remember that you have to align the dot in the highest score of 90 for the test Y, also down to the test X of the score of 72. Another, he get the lowest score in the test X of 70. Now, she or he will get the highest score in the test Y. So, as you can see, it's really opposite in the test Y and test X. And lastly, in the test X, she or he get the score of 68, which is, it is a lowest score. Now, in the test Y, the opposite of this is 98, so she or he will get the 98 of score. Let us connect the data in the line graph so that we can create the simple correlation line graph of perfect negative correlation of tests X and Y taken by 16 teacher education students. Now let us connect the line graph, the dots. So as you can see in our line graph, in the test X, it states that it starts with a 98, the highest score of 16 teacher education students. Now it increases to the test Y of the data. Now in the test Y, the student get the highest score, but as you can see in the line graph, it goes down, it decreases. Now, that is the perfect negative correlation of this line graph. And now, we are done discussing the simple correlation line graph of perfect negative correlation of tests X and Y taken by 16 teacher education students. Now, let's proceed to the second discussion. And for our next topic today is all about the Pearson product moment correlation coefficient. So, what is Pearson product moment correlation coefficient? When we say Pearson product moment correlation coefficient is a linear correlation essential to determine the degree of relationship of two sets of variables X and Y. Pearson product moment correlation coefficient. The first thing that we must know here is what do we mean by correlation. So when we compute for the correlation, we are computing for the value of how strong the relationship of one variable to another variables. It means to say that the correlation, we are computing the value for us to tell how long the relationship of one variable to another variables. We are talking for the variables that are quantifiable, variables that are quantitative. So I have here the formula of Pearson product moment correlation coefficient. Now, let us discuss what is this formula. So to begin with, R is the symbol of the correlation coefficient. So Rxy is correlation between the X and Y is equal to the N is the number of cases, summation of the product X and Y minus to the summation of X multiplied to the summation of Y all over the square root of N, or the number of cases in summation of X squared minus the summation of X quantity squared and number of cases summation of Y squared minus close and open parenthesis summation Y quantity squared. So that is the formula of the Pearson product moment correlation coefficient. Now we are done discussing the Pearson product moment correlation coefficient, also the formula. Now let's proceed to the steps that we need to follow if we apply this formula. So for our step 1, look for the sums of x and y, and step 2, square all x and y values to get x squared and y squared. And for the step 3, find the sum of x squared and y squared to get the summation of x squared and summation of y squared. And step 4, multiply the x and y to get the xy. Step 5, look for the sum of xy to get the summation of xy. And last step is a step 6, solve for the correlation using the formula. And now, let us proceed to our last topic, which is the interpretation of correlation value. So in the interpretation of correlation value, it states that how we interpret the correlation value that obtain to those classifications in the interpretation of correlation value. Now, I will present to you those classification in the interpretation of correlation value, and let us explain one by one. To begin with the interpretation of correlation value, so an R, or the correlation coefficient, plus minus sign 0.00, it denotes the zero correlation. So it states that it indicates with no correlation. So an R, or the correlation coefficient, from 0.01 to plus minus sign 0.20, it deals on the negligible correlation. So when we say negligible, it means it is insignificant correlation. So next is an R, or correlation coefficient, from plus minus sign 0.21 to plus minus sign 0.40. It denotes the low or slight relationship. So if the interpretation of correlation value, if the correlation coefficient from 0.21 to 0.40, you can expect this as it denotes low or slight relationship. Next is an correlation coefficient from plus minus sign 0.41 to plus minus sign 0.70. It indicates or mark or moderate the correlation. So next, an correlation coefficient from plus minus sign 0.71 to plus minus sign 0.90, it shows high relationship. And next, an correlation coefficient from plus minus sign 0.91 to plus minus sign 0.99, it denotes the very high correlation. So if the interpretation of correlation value of correlation coefficient plus minus sign 0.91 to plus minus sign 0.99, so it indicates with a very high correlation. So lastly, if an R plus minus sign 1.0, it indicates the perfect relationship. So if the data of the interpretation of correlation value, correlation coefficient plus minus sign of 1.0, so it indicates with a perfect correlation or relationship. So we are done. That's all for today, everyone. I hope you get some information about my report today. Thank you.